Hello viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about combustion engine emissions. Not only CO2, but what about other things? So let's dive deep into it. Now, what exactly is the problem? Well, if you studied any chemistry in school, you know for a fact that if you burn hydrocarbon, let's just say methane, all you're supposed to get is basically water vapor and carbon dioxide. But combustion in real world is highly chaotic event, meaning things don't go according to plan. And burning hydrocarbon should just give you basically vapor and carbon dioxide. Outcome is we get a lot of unwanted toxins. And yes, toxin is the correct word because almost all of them can kaput a human surprisingly easily. So we get what sort of gases? Well, we get NOx, very naughty puppy. It creates acid rain and really bad for us. And then you have carbon monoxide, ultra bad for us. I'm reasonably sure you studied this in biology. And then you have hydrocarbon, which is also naughty simply because it's not digestible. Now be mindful, all these things exist in nature, just the quantity and location is such a way that it's always away from humans. As in, like, yes, a burning forest will have carbon monoxide, but yeah, it's a burning, you have bigger problem. So humans created a scenario where these things are next to us. That's the serious problem. That's why, like, all of it is flat out poison to us, meaning if we would not have taken care of these things or at least reduce them substantially, we would be kaput by now, like flat out. To remove CO2 just by carbon monoxide and just by NOx, we would have been dead, done, go home. So this is a genuine problem. It's not something that you can ignore. And yes, there are a lot of people who have almost hatred towards combustion engine for this exact reason, and it is almost justified. So how do we deal with it currently? Well, we have a paradoxical relationship. For example, ideally, to reduce CO2, you want to burn as little fuel as possible. Well, to do so, you want to utilize physics. Physics says, hey, if you want to get more work done, increase the temperature. Basically, go as high on compression as possible and as high on temperature as possible. So your T delta, basically, let's say your ambient temperature is 50 degrees Celsius. Instead of burning at, let's say, 1200 degrees Celsius, you yielded it up to 1500 degrees Celsius, you get more useful work out of it, more efficiency, less fuel combusted. However, that creates NOx. So that's a very serious issue. So to give you how big of this paradox is, we know petrol is low efficiency, as in you can look into Wikipedia's BSFC chart and go into other companies also, they provide you with, especially if they are selling engines only. Best case scenario, like really best case scenario, you're gonna get around 20 grams of fuel combusted to give you 1 unit of electricity at its sweet spot. Diesel, basically be it Scania or be it Cummins, they generally can easily touch 180. Is order and magnitude worse in case of petrol. And the world's best heavy fuel oil, basically again compression ignition systems, those puppy touch 150. They are very efficient. However, petrol, we like petrol because it has a low NOx emission. You will keep hearing petrol does not have pollution because it does not have NOx, so to say. So how do we deal with it? Well, you burn your petrol and it has stuff, right? Combustion is a dynamic event. You will not get everything precisely done. So what is the outcome? Outcome is basically hydrocarbons that are unburnt, then you have carbon monoxide, and then you have NOx. So NOx goes into reduction stage. Now reduction stage is basically a giant heat exchanger which has giant surface area coated with catalyst metal. And I'm reasonably sure you remember catalyst is something that facilitate action without being consumed by it, meaning this can help things to happen without being consumed. It's not a consumable item, but generally does require certain motive. In this scenario, motive is temperature. This puppy will not work if it's at 0 degrees Celsius. It needs to be hot. In some designs, as hot as 300 degrees Celsius, or maybe even hotter. So you take that heat energy, catalyst suggests some things. So catalyst takes NOx and it's like, yo, man, why so naughty, man? Just chill, man. So it chills out into oxygen and nitrogen. Easy, non-toxic, easy, safe, normal. Now here's the funny thing, that oxygen now goes into oxidation stage. In that stage, carbon monoxide starts to react with oxygen, meaning now you are getting carbon dioxide, which is safe. This is the primary reason we are not dead. Like, and be mindful, this thing is surprisingly efficient. And if you ever looked into your car electronics specifically, why does it have so many oxygen sensor? For this, Like we have built such a sophisticated and actually working system where we have oxygen sensor before air goes into your system, as in like engine, after coming out of engine, after coming out of exhaust, so we can monitor it real time, and there is a closed loop feedback. Because be mindful, if you are running super duper lean, as in like the very little fuel, lot of air, this will not have enough oxygen to do all the oxidation layer. And if it's too cool, like you're just not enough heat into it, the reduction layer will not work. So engine control unit is actually fighting real time. Sometimes it will like, okay, for this pulse I'm gonna give more fuel. Okay, temperature starts to go up, go up, go up, it reached the steady state. Okay, now reduce it. Okay, it's gone two down, like literally fighting real time to make sure that this operates perfectly. Now, how efficient this is? Well, if done even remotely logically, this will start at 90%. And if you've done really well with oxygen sensor and feedback loop, 94 to 95% is doable. This is the reason we are not there. Like flat out, all the cities, all the traffic jam, everybody would be dead if this was not working. So this is really important achievement of humanity, and the fact that now we have closed loop, and this is the primary reason we have basically OBD2 ports, is that this works. And here's the deal. Same physics, higher compression, more temperature equal more efficiency. Diesel does that. Diesel inherently is like 1 or 2x bit more compression. Like let's just say, just go with the numbers. You are like 1:7. Diesel is like 1:15. It generally does not go that stupid high, but it can go. And the penalty of that, it gives you lot of oomph, lot of energy. Awesome. But it has a lot of NOx. Why? Because diesel generally runs air rich, very air rich. Like there is rarely a scenario where you are running what we call rich in diesel system. Generally you're always lean, so that creates a scenario where you have way too much hot nitrogen. Now there is this graph. Now this graph says basically once your local temperature, where the boom event is happening, once it starts to cross 2200 Kelvin, it starts to go into NOx territory, meaning nitrogen is no longer inert at that point in time. It will start to bond with things. So at that point in time, the more compression, the more energy yield you get, but you also get ludicrously high temperature, and that temperature creates inert nitrogen into non-inert nitrogen, and it starts to react with all the free oxygen. Why do you have free oxygen? Because it's air rich. Tada! NOx emission. And it's bad. Let that be very clear. It is bad. When people say diesel is polluting, it is true. Like if you have to get 1 megawatt hour energy out of a diesel system versus a gasoline system, you are looking at difference of NOx by 2 to 5x. Like this is fundamental. Now be mindful. It is ironic simply because carbon dioxide emissions would be lower in diesel. Like the amount of carbon dioxide you are putting in the atmosphere would be lower. You see, chicken and egg scenario, almost a paradoxical relationship. And there is another aspect of it. Diesels do not like cold start, because again, the fuel is compression based. Compression relies on certain amount of temperature. If you have fuel going, that's how fuel injector works. When you have that, if you do not have enough heat, the combustion will happen. It's just, it will create too much soot. That's why when cold start happens, you get the black blur. And that is particulate matter. That is so bad, it's gonna kaput your lungs instantaneously. So NOx is very bad. Cold start is, now again, it's not an issue for diesel system because people have learned it that way, that diesel engines are put on big things. You start, you forget about it. Like let's say look at locomotive. They start the engine, it could literally go on for 1 or 2 days before they shut it down. Look at a container ship, they start it on and they're like, bye-bye. For maybe it will be running for a week or maybe more than that before they turn it off. So we generally push diesel to a much heavier load case. So cold start is not that big of a deal. But soot and particle matter creation is an issue. Unless you like put the diesel perfectly, yeah, that will be created. So not only it has NOx issue, it also has soot and particulate matter. Although solvable, NOx is very difficult. Like soot and all that manageable. Basically, this NOx is so bad that modern diesel engines, if you buy it, you will find DEF. Basically, we are putting either ammonia or like for a urea there to combust that puppy. Basically, manage NOx, because again, per unit of energy, NOx creation is higher in this. Why? Because it's efficient. Why? Because it has higher compression and higher temperature. And higher temperature does not like nitrogen and oxygen being in the same place. So this is our current situation. We have made amazing progress, but we are reaching certain limitation. So how do we reduce pollution? Well, the easiest as of now, without changing anything, jump into hybrid. Why? Well, many people complain that we have like, every time engine is more efficient, but our fuel consumption keeps going up. Well, simply because we have maxed out roughly how efficient an engine can be, like paper-wise, mathematics-wise, engineering-wise. We kind of like, we got this. All we are doing is expanding the power band. Right now, basically, mileage was locked at 1990. After that, it's like, okay, we can give you good torque at low RPM. Okay, we can give you good, snappiness at high RPM. That's all we are doing. We are trying our best to expand the power band. Engine has reached a point and like almost fall after that point where it's like, yeah, we have reached a plateau. We can't do much about it. And like, it is so bad just to expand the range, especially in the lower RPM. We have exhaust gas recirculation, just so we can choke the engine and it behaves like a smaller engine without creating too much pollution. And like, okay, how the heck exhaust recirculation helps in that? It reduces the combustion temperature because it's inert. It does not react to it. It saps energy from the boom event. And again, your engine also does not loses energy in breathing simply because it's not sucking. It's like, it's like, so it's done that. And be mindful, it only applies on lower power band, meaning it does not affect your like full GG horsepower. It affects when you're like cruising in traffic. So you can understand that like all our engineering, you look any engine that is in market and let's say just introduced into market in 2020, half of the things on it is just to expanding the power band. Actually, I'm joking, it's not half, it's 75%. So basically we have exhaust recirculation. You must have seen variable valve timing. All of them are just trying to expand this sweet spot. Sweet spot is fixed, like based on the design and geometry and all that. All engines will have a sweet spot, meaning at the right amount of torque, at the right, as in load, at the right amount of RPM, it will take the least amount of chemical fuel to maximum amount of mechanical work. As in this engine design, you can achieve 225 grams of fuel combusted and you're going to get 1 unit of electricity if you are running at, let's just say, 2500 RPM and torque on the shaft is 70 Newton meter. That's a sweet spot. But here's the ironic part. If you reduce the load, you're like, okay, what if I reduce it? Wouldn't it get better? No. It will start to choke. And outcome would be you will drop to 700, meaning you're burning more fuel to achieve same work. So that is why all the engineering you see on engines is just to expand it. Oh, we're going to have variable valve timing. We're going to have like variable compression ratio. We're going to have this and we're going to have that. All of them is useless. All of them is trying to expand the sweet spot. Physics says, nah. Like we have been trying it. And if you are not like, okay, why the heck my car does not give ludicrously high mileage? All the mileage that you are gaining, you are losing by all the crap that is put onto your engine. So that is it. And ECU, it's a black magic now. It has so many levers that it has to balance real time. Like it has to make sure the load is maintained. As in like if you are pressing the accelerator, it's its job to like, okay, this is what the pilot wants. Let's make sure that it's delivered. Then it also have to maintain the catalytic, not too hot and not too cold because it will get kaput. If it gets too hot, if it's too cold, it will not work. So catalytic temperature, it has to make sure the temperature is right and oxygen. And then also have to make sure the exhaust gas recirculation applies when you're based on your load. All these systems, that's why modern car engines are so what you call finicky. And here's the take the same engine manufacturer, let's say Fiat, Scania, or whatever, Cummins. Take all the same manufacturer, go YOLO on it, whatever you want, a cat engine or diesel engine, whatever have you. Say to them, what is the BSFC? Okay, they will tell you, whatever engine, there will be a sweet spot. Remove everything from it. Basically, throw away the variable valve timing, throw away the exhaust gas recirculation, throw away everything. And you will still have a cleaner output. Why? Because you tune it. Right now, your ECU is fighting in real time. It's like, and this is the outcome of it. It cannot stay there because, again, load is variable, but it and is trying its damn best to make sure that you're not polluting everything. It can't do that. Like physics is like, nah, bro. But if you are like, okay, you stay here, like this is the sweet spot, you stay there. And the only variable you have to adjust is ambient temperature, aka your coolant temperature. ECU is like, I got you, fam. I got you. I'll start the engine. Engine will go to the sweet spot and you will have the most amount of converted energy. As in chemical went inside, energy came outside, the best conversion efficiency. Every aspect of ECU can be fine-tuned. You can easily throw away the variable valve timing, easily throw away the engine exhaust circulation, everything, including what diesel particulate matter filter. You can also, that's why they do not come in static generators. If you are fine-tuning it, like this is the operating range, especially if you are not on, off, on, off. If you are like on, stay on, done. Like you would be shocked how much stuff we are adding just because we have one dynamic power band. Throw away the dynamic power band desire. Have internal combustion engine, have a motor generator unit running from it, send that power to battery, send battery's power to motor generator second number, and drive that the wheels. As in how a dam works. Basically, river gives you a constant output, you have a reservoir, and your electrical load varies. You control it from the reservoir water, not the river water, reservoir water. same thing you're doing. Your total efficiency will go up and your emissions will go down, and not to mention your engine will become easier. And again, this is the exact issue Edison is facing right now. They have the engine. Engine is legally certified by all the Euro standards and all that jazz. They just can't put that goddamn engine on the rolling chassis, because according to rolling chassis, it has to have a same emission standards for basically a vehicle engine. But it's like, it's not a vehicle engine. It's not even touching vehicle. It's like, it is just spinning a generator. That generator is feeding to battery, not even motor. It's not like a series hybrid train. Its battery is there. So it is far more efficient. Cleaner, like on the same governmental system. It's just that you can't put it on top of a truck. So that's why they are failing. And this is Thomas Evie, exact same philosophy. He's working in India and he did something even better. It's like, okay, we have a giant battery bank. Cold start is really ugly. Like half of your issue with diesel system is cold start. Cold start as in like, not cold as in like Alaska cold, cold as in ambient temperature. 60 degrees Celsius Indian ambient temperature. It's not hot enough, so to say. So he figured out, what if we spin the basically engine before it reaches the temperature. Like you start to spin it up 2 minutes, 3 minutes, 5 minutes, you have the glow plug firing all the way, may even have basically coolant heaters. Again, it will be done in the future variations. Right now it was just glow plugs and kept running for 5 minutes. Again, if it had coolant heater, it would be taken like 2-3 minutes. It reaches sweet spot temperature, then they ignite the fuel. Ta-da! No black, done, problem solved, go home. Like legally, like you have emission stand, this topology can remove that issue. It's like, bro, don't worry about it. You are fighting for Euro 6, I am at Euro 7. That can be done. You can remove, basically downsize the engine. Engines are overbuilt just for that overtaking scenario. You downsize the engine. No transmission. Transmissions are big and heavy. You kaput that. You do not have exhaust gas recirculation because again, everything is tuned for that one sweet spot. You do not have a diesel particulate filter because again, combustion is designed for that system. It's like, it's good. We got this. We're good. And again, that's why like static generators done by good brands do not need it. It's like, we don't need it. And again, if you do basically what he's doing, you don't even have to worry about cold start problem. So hybrid right now solves not only CO2 problem, it also solves emission problem. Not doing that is genuinely stupid of humanity. And again, I'm giving you 2 countries example, India and Canada. Oh, and every submarine ever made. Oh, and every diesel locomotive. They are like halfway there. I'm in talks with someone there. They might add giant supercapacitor banks to smooth that out in a locomotive also. So that emission will also become better. So that's the hybrid. That's the easiest way you can reduce emission and pollution at the same time. Now we come to petrol engine's biggest development in recent time, jet ignition. So basically, whenever you need spark ignition, be it ethanol, be it gasoline, in those sort of scenario, you want very high pressure. But again, pressure is upper limited by NOx limit. Meaning you can figure it out, and let's just say by 11 you're gonna go kaput. So you're gonna be at 10.5 compression ratio. But you want temperature to be high. You want like fuel and you're like boom. But again, that will give you NOx emission. So how do you get high pressure and high temperature? Pressure is limited. You can't go beyond that point, but you try to push as close as possible. Temperature, as in how much fuel you want to put into it. You can do that. And this will allow you to not have NOx. How? Well, simply because you have a pre-chamber. Now, this is the pre-chamber. So pre-chamber is a fuel injector plus spark plug, and it is above the main combustion chamber. So you go before just about to do before the spark plug will fire normally, you will do this step. Basically, you will flush the fuel. That area would, because again, you are doing it after compression stroke, there is enough air there. It's very rich, so to say, and you kaput that. Benefit of that, it creates a jet. It creates that whoo, instead of a minor spark that's like trying to do its best. It's literally like flamethrowers. Multiple of them, like 4 flamethrowers, 6 flamethrower. I've not seen any design lower than 4. So that's what it is. And that burns everything too goddamn quickly. Like time becomes your another variable you can control. As in compression till a knock happens and then ignite the whole mix, the fuel and air mixture kaput. One shot kaput, the end. And you can even do very lean mixture, which again, people don't like simply because if you do very lean while doing very high compression, you will get a lot of NOx. Here you will not. You can have very air rich, very high temperature. And why don't you have NOx? Because you do not have what we call residence time. As in how long that temperature was there. As in, like, nitrogen needs time to react, right? It cannot just like temperature happened, nitrogen reacted. That's not how it works. It needs time. So what they are doing, basically, the gap between spark plug and jet ignition system is magnificent. As in millisecond to microsecond, that kind of jump happens. That's the whole point of burning it so instant. It's like just like done, go home. And in terms of like when you're talking about speed in engines, they are achieving complete combustion in 5 degree to 10 degree crank rotation. That's fast. That's like done, sir. Go home, sir. Go home. And again, this is becoming the new standard for F1 by 2026. And at least 5-6 companies have already started working on it. And there are certain luxury road cars that are practicing it. Like, the results are in, it actually works. Question is, how do we cheapify it? It's like, it's done, science is done, science is sorted. And basically, you are removing time variable. You're like going bonkers in terms of pressure up to the upper knock limit. And you are increasing the temperature as hot as you can get it from combustion, as in like fuel rich if you want to, like really fuel rich. And you can even do lean, because again, there won't be enough time for NOx to form, and you get more power. So emission goes down, power goes up, and NOx kaputs. And basically what we are trying to achieve is what we call in engineering constant volume combustion. If you can ever achieve that spot, constant volume combustion, NOx almost disappears. So this is almost getting us there, where it's like NOx emission without a catalytic converter would be like, bruh, we good. So this is jet ignition. This will become the new normal until somebody figures out how to make it cheap. It's there. It's just somebody has to figure out how to do it cheaply. Then we come to diesel. Now let this be very clear. Diesel is a naughty puppy. It will require certain oomph to do this. And there are many strategies. Same way, petrol is like almost every company has like, this is the best thing we can do. And this is what is going to happen from, let's say, 2025 to 2035. That's what everybody's going to focus on. But when it comes to diesel, there are a lot of strategies that people are working on. So you have basically injection phasing and fast burning. For example, this is from Bosch. They want ludicrously high pressure fuel rail. And that is soot reduction's best friend. The higher the pressure, the smaller the fine particulation, and the less chance you have for soot creation. And instead of having one boom event where it's like kaboom, you want to do. So they have pre-injection, and then one pre-injection, second pre-injection, then main injection, then they have post-injection. Like, why the heck you have post-injection? To make sure the catalyst temperature remains the same. So, or remains at optimum point. So this ultra high pressure requirement for, because again, that will solve the soot issue, and rate swapping. Basically, you are not going one kaboom, you are going boom. So that way we can reduce emissions a lot. Now be mindful, some variation of this is already being tried in diesel systems. We are working our ass off to either reach a point where it's almost reaching a jet ignition or overflow it with the air. So you get full combustion with minor amount of diesel, but you have so much air that temperature does not go up. Almost like how we run rocket engines. Rocket engine goes to stoichiometric ratio and then overflow. Like in case of space shuttle, they will overflow hydrogen. Why? If you overflow hydrogen, hydrogen will convert your temperature into flow. Flow will give you thrust. We are doing the same thing. We want push. We don't want temperature. We want push. So what is the next best thing? If you can't get like the full combustion, like air fuel mixture, if you can't have that luxury, what is the next best thing? Overflood it with air. As long as you can make fine mist enough, you can achieve that point. Basically, complete overflowing of air. So temperature never reaches 2000 Kelvin and you're like, we good, we got this. So that is there. And soon it will be very possible. Like, again, I have like a lot of options, and be mindful, this is what we have already achieved. Basically, we started with Euro 1, that was in 1992. So NOx emission grams per kilometer was around 0.9. So, and basically particulate matter, the soot part, that part was 0.16. And again, soot's best friend, as in like best enemy, is high pressure. The more fine mist you can make, the kaput you get. Like, that's the whole point. You just want to burn that puppy like there is no tomorrow. So that gives you 0 there. Then we reduced basically this a little bit, little Euro 2. Then we reduced a little bit. Now we are almost reaching Euro 6 is right now active, and you need to change the scale. That's how good we have become. So let that be very clear. Just people saying, oh, diesel is bad. Yeah, it was. we have made amazing progress. And I can guarantee you, like, either hyper lean designs will be successful in diesel tomorrow, or like somebody will figure out how to have kaboom event here. That's the only thing missing. If we can detonate it very quickly, that rapid, like not just like, oh, it's gonna boom, like rapid. That's the whole point. From milliseconds to microsecond, we're just like, if we can do that, diesels will also become clean. At that point in time, there will be no reason to have gasoline. If we can actually achieve that, no reason to have gasoline. And again, if that is achieved, we will no longer need extra fluids to clean the exhaust. So that is to it. And be mindful, right now you can remove all those extra fluid requirements, because if you shrink the power band in hybrid system, you're already solved it. Have ludicrously high pressure rail system, no problem. Fine tune the ECU for that sweet spot, done, go home. You can meet all of this. Like, I'm working with the engine company, we are trying to meet Euro 7, not even dealing with Euro 6, like directly go for 7. So it's already out, the standard is already out. So it is doable, let that be very clear. Jet Ignition will take care of the basically petrol engine in next 5 to 10 years. And this puppy will take some time, but it will happen, it will happen. And again, if you do not want to go through this route, go through the hybrid route. And if you're not doing it, that is stupid. So this was my presentation on basically emission side of the game rather than just the CO2. So I hope you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.